Installing a multi-node Kubernetes cluster involves steps like creating multiple machines, ensuring that all these machines or nodes can talk to each other. Then you install Docker, Kubelet, Kubeadm, and Kubectl. You initialize the cluster on the master node and asking your worker node to join the cluster using Kubeadm, installing the CNI, which is Container Network Interface, so that pods can talk to each other and your Kubernetes DNS can start, and finally checking the status of nodes and pods to verify that cluster has set up correctly. By end of this episode, you will be able to create your own 3-node Kubernetes cluster, so you can use this Kubernetes cluster to practice other hands-on lab activities. And this multi-node Kubernetes cluster setup is important, especially when you're preparing for Kubernetes certification. That's Certified Kubernetes Administrator CKA or Certified Kubernetes Security Specialist, that's CKS. In both these exams, you should be very well versed with installing and configuring Kubernetes cluster. So how to create a 3-node Kubernetes cluster using step-by-step procedure so that you can install it in your own setup. I'm going to cover all this in today's episode. Welcome to another episode of weekly video series on Docker and Kubernetes with me, Atul Kumar from team K21Academy, where we take you from complete beginner, covering microservices and Docker, to all the way on install and configure Kubernetes cluster, including networking, storage, deployment, pods, and scaling your Kubernetes cluster using horizontal pod autoscaling, including how to prepare for the certification exam CKA or CKS. So before I tell you how to create a step-by-step 3-node Kubernetes cluster, I've taken a clip from one of our certification training program on Docker and Kubernetes for administrators, that's CKA. And in this clip, our instructor, she's going to tell you the overall setup where we're creating a 3-node cluster. So what all software we'll be installing on a high-level overview in a few minutes. So this is a clip taken from the module on install and configure Kubernetes cluster from the training. Then I'll go and create all this so that by showing you actually creating these on the console, and you can do that same setup with me. So by end of this, you'll be able to create a 3-node Kubernetes cluster with me. So let's see first what our instructor have to talk about it.
Let me explain what exactly we are planning to create. We are creating 3 nodes. So one of the nodes would be the master node. And first I'll bring up this node and name it as master. I'm naming it as Kubeadm master. And here you would be obviously installing Docker, and then you would be installing kubelet, because system processes also would run as containers. So kubelet and Docker are the 2 daemon processes. These would be running as daemon. They would not be running in containers. So these 2 are daemon processes. And then we would be installing Kubeadm tool. So I'm just writing the tools which we are installing. I would be installing the Kubeadm tool, using which I would be setting up my cluster. I would install the kubectl or Kubectl. Few people call it as Kubectl as well. So Kubectl or kubectl is the command line interface. This is the client interface to talk. This is the cluster creation tool. You can say cluster creation tool. And you would also make sure that you set the configuration so that from the command line you can talk to this cluster. So this is my master node. Let me bring up 2 worker nodes as well. So we would bring up 2 worker nodes, worker node 1 and worker node 2. So here this is worker 2 and worker 1. And we would have same way Docker in this, we would have kubelet in this, and we would install kubectl. We are doing kubectl in all the nodes, and if needed we can run the commands from there as well, but kubectl is normally installed in the node from where you plan to run the command for the talking to the cluster. After installing these tools and bringing up these daemon processes in all the 3 nodes in the cluster, you will have to set a cluster or networking across them, and that is when the CNI interface will come into picture, and we would use one of the CNI plugins and we will install. And when we do the installation of the CNI plugin, that is when the nodes come into ready state. Unless and until you install the CNI plugin, nodes will show that they are in a cluster, but they would not be in ready state. So we would follow few steps. First, you will initialize the cluster with kubeadm init command. This is run on only master node. With this, the cluster initialization happens. Second, you would be running a kubeadm join command on the worker nodes. So worker 1 and worker 2, you would be executing these commands in which it says that this node is joining the cluster and this node is joining the cluster. And third would be the CNI plugin installation. With this, your cluster should be up and running for creating your application container.
So that was a clip taken from one of the lessons from our step-by-step training program on Docker and Kubernetes for beginners, including certification CKA or Certified Kubernetes Administrator. Now let's begin with installing this Kubernetes. So as I said at the start, first we are going to create 3 machines, and then we'll be making sure that all these 3 nodes can talk to each other. Then we'll install the software Docker, Kubelet, Kubeadm, Kubectl, initializing the Kubernetes cluster using Kubeadm, and then join my worker nodes onto this Kubeadm. We'll be installing then the cluster-wide CNI, so my nodes can talk to each other on a Kubernetes cluster, including setting up my DNS server. And finally, I'll check my node status and pod status. Now, if you want to mimic this, you can install 3 machines on your laptop under virtualization, but I find it very difficult, especially a bigger spec machine, unless you have a bigger spec machine. So what we are doing is we are creating these 3 machines on Microsoft Azure cloud. Now you can do it on any cloud of your choice, but we are doing it in Microsoft Azure because we do a lot of trainings on Microsoft Azure. So we find it very easy to create an account, also create these Linux machines that will be part of our Kubernetes cluster. So if you don't have a free account on Microsoft Azure, you can go to K21Academy.com/Azure02. I have a step-by-step video using which you can create a free trial account. You get $200 credit, which should be more than enough for you to practice. So I've already created an account and I'm going into my Azure cloud account and then ready to install Azure Ubuntu machine on that. So I'm in my Microsoft Azure cloud account. Inside that you search for virtual machine, or you go to the search box and click on virtual machines. From here, click on add and create virtual machines. Now, if it's a fresh account that you've created just now, you first need to create a resource group. And resource group is nothing but collection of resources. In this case, virtual machine. We'll be setting up some network or different machines. So we'll create a new resource group called Kubeadm. You can name it anything of your choice. Click on here, and now you specify the machine name master, or I'm going to specify because first I'm creating a machine master node. So I'll specify that as a master node. Region, I'll leave it US East US. This is the region in which I'm creating this master node. Now I'll leave all the availability option default. Again, I don't want to go into these additional topics where these additional topics we cover in our Azure Administration Certification AZ104 training. So for the timing, we'll leave availability options as none. We don't want high availability for this machine. And image, we are going to use Ubuntu. So my both master node and worker node will run on top of Ubuntu. Whatever is the latest version of Ubuntu you see, you select that. Make sure you can keep other options default. So in order to connect to this machine, I can use either SSH public key or I can use password. So I'm using password and I'll specify the username just to remember Ubuntu, and you specify the password. This password we'll be using at the time of login, and we are allowing port number 22 open. And then under networking, I'll go and click on networking, and it's going to create a new networking virtual network in which my machine will be created. So it will create a network with default subnet. Inside that, it'll create a machine with a master IP or one of the IP addresses as a public IP. And you go at the bottom and click on review and create, and you'll be able to create a machine. Now, this is first machine we have created. Now, similar to that, right now, Once its review is done and review and create, once review is done, you have to click it one more time to create a machine and click on create. Now, if you're not familiar with, and if you want to go a little bit more deep into these options which I've created, we have a blog on coming from our AZ104 certification program. So you can go to URL k21academy.com/AZ10420, where you will see step-by-step procedure to create virtual machine. Whatever I've covered, maybe a little bit deep with options available. So now, probably you will see shortly that machine has been created, a master node has been created. It'll come here once machine is created. Now, I've created just a one node, which is master node, and I need to create two more machines on that acting as a worker node. Now, typically, ideally, I would be creating these two worker nodes also in the same network, in the same region as your master node, so that there's no network latency. But if you're doing it on a free trial account, you will not be able to create all the three machines in one single region because of the limitation or soft limit that you have because it's a trial account. So what you can do is you can create other two machines in a different region. So let me show you how do you create two other machines in a different region. So I'll go back to here again onto the virtual machine and click on virtual machine again. I'll specify the same resource group which I created for my master node, which is Kubeadm. And here this time I'll say worker01. And this time I'll be creating in a different region, maybe South Central US, or you can pick any other region of your choice in US, because of my first machine is also in US, but that was in East region. Rest all is going to be same. I'll be using the password again. I'll specify the same user ID. Now, one thing to important note is I'm going to the networking section, and here it has created a new network now. So earlier I was in region 1. The network is limited to a region. So earlier I was in region US East, so that created a network. Now I'm in a second region, which is US Central. So it has created a new network called Kubeadm VNet 717. And it's given me a new subnet and new IP address. So I'll create another machine. This is worker1. So here, once the validation is completed successfully, click on create. So now I'm creating my second worker node, but in a different region. So I've created this master node. I've created this worker node in a second region. I'm going to create one more worker node, which is worker node 2 in the same US South Central region. So I'm on a virtual machine again, click on add and say virtual machine, same resource group, but this time worker-02. And I'll specify the same region as my other worker node, which was South Central US. Rest all same, Ubuntu machine. I'll want to use username password. Now you can also use SSH keys, but not everyone is familiar with SSH keys. So I'm going to use username and password here. Make sure that 22 port number is allowed. You can connect. And then I'll go on networking. And if you remember in the previous or when we were creating worker node 1, that time also it was Kubeadm VNet 717. So my second worker node will be also in the same network as first worker node. But this network is different from my master node network. So once it's reviewed complete, say create. So it's review and create, and it'll now, once review is successful, I'll again come back and click here and say create. So you need to look at twice, otherwise it'll only review, not create it. Now I've gone the steps and saying it's submitting the deployment. Here you can see the notification, which is showing deployment of worker node is in progress. So I'll go back here, virtual machines, and now after a few minutes, you should be able to see 3 nodes here. So within next 5-10 minutes, you come to the virtual machine tab here and click on refresh. You should be able to see 3 machines, one master node running in a region East US or whatever region you selected, and other 2 worker nodes will be running on a different region. So I have 3 machines, all 3 are running. So that means I've created these 3 machines. Now next is I need to connect these 3 machines with each other. Now, because I created my master node in one region and my worker node in a different region, they both have a different network, and the machine in this network should be able to talk to the machine in another network. And in order to achieve that, we configure something called as peering or VNet peering. I'm going to show you in a minute how to do that peering so that a machine in one network can talk to machine in another network. Now, apart from that, The worker node will talk to the master node on a particular processes on a specific port number, and similarly master node will talk to a specific worker node on a particular port number. So those ports should be allowed. So for example, the master node, I have my Kubernetes API server listening on 6443. So that port should be open and so on. Similarly, on worker node, my kubelet API port number 10250 port should be open. If I'm using node port, which is another type of service, which is for network service, which is listen for my pods service or pod applications, then my node port services port number should also be open. Because it's a test environment, I'm going to open all the ports between master node and worker node. And the real production environment setup, you should allow only the required port numbers as mentioned in this document. Now, this video will also be updated on our blog, k21academy.com/Kubernetes 30. In that blog, I'm going to specify the documentation link that will tell Kubernetes documentation on what port should be open. So let's go and configure the network peering between master node and worker nodes, and then also the port number, open the port number between master node and worker node. So if you want to see my network for my master node, click on the master node, and then under networking, you see here virtual network subnet. My virtual network is Kubeadm VNet for master node. Similarly, for my worker node, my virtual network is Kubeadm VNet 717. Similarly, for my worker node 1 also, it should be 717 Kubeadm 717. So Kubeadm VNet 1717 should be paired with my Kubeadm VNet. So I'll go in this VNet virtual network. You can either go from virtual network from here, or you simply type and say VNet virtual network. And this is my master node network, and this is my worker node network. So I'll go into the master node network, under go to peerings and say add a peering and say K8S peering. Just give a name on this. And I'm going to use a deployment model of VNet network deployment model of using resource manager. My virtual network is, I'm configuring my Kubeadm, and the name of this peering is from Kubeadm VNet 71 to Kubeadm. So whatever name you want to give, we'll specify that name and say this. So I'm saying ADM. So name of the peering is master to worker. So I've enabled master to worker and also worker to master both ways. I'll also enable the forward traffic settings, and here both enable all these four and click on OK. So this will peer these two networks. So if I go under Kubeadm VNet, this is my master network. I see Kubernetes peering. If I go under the worker node, I'll see other way master to worker. So these two networks are connected now. One final thing I will need to do in order for connectivity is I'll go to the virtual machines. I'll go to master node, and I need to allow the port number, all the port numbers. I can specify the limited ports, but because it's a test environment, I'm allowing all the port numbers. So I'll go to networking, and here this is my inbound incoming connections. So idly I add a inbound port number, and here idly for the master node, I should specify these port numbers, and for worker nodes, I should specify these port numbers. But I know the process, so I'm going to, for time being, specify all, and I'll say port all. Give a name and say allow all port. Add, and this will now add, and it will allow all the port numbers. And now this in a production environment is not a secure way, but because, as I said, we are practicing it here, so we'll configure allow all. Same here on worker node 1, allow connections all, star, click on add, and similarly I go to the second worker node and add. So that completes my network connectivity, where my machines can talk to each other, and I can connect to these, or I should be able to connect to these machines. And now before we go to the next section where we install all the required software, which is Kubeadm, Kubelet, all the other required things, and Docker, let's first see I can connect to these machines or not. And you also try out, and in order to connect, you need a SSH terminal like PuTTY. So you go to the master node, and you need to find out the IP address of this master node. So if you go to virtual machine, master, and here under the public addresses, on here under overview, you copy this public IP address, and on your PuTTY, specify the IP address of the master node and click on open. You will see the fingerprints and say accept, and now you'll be logging in as Ubuntu user. I've logged into the master node, host name, it's my master, and I can now switch to root user by sudo space su minus, and I'm root user. Similarly, make sure that you can connect to the worker node by going to this address and then connect to PuTTY on public IP on the worker node. I've tested myself, but I also want to do one final check, which is my master node can talk to this worker node. So I've taken my master node IP and I'm saying SSH, and Ubuntu is my username, and the IP address of this public IP is this. I hit enter and I can connect, and it's saying, do you accept the fingerprints? Yes, say yes. And then password for this. So my master node can now talk to the worker node. And if I say host name, I have worker 01. So my network connectivity is done. I have 3 machines already with me. So the task 3 is going to be, I need to install some software, which is I'll be installing a Docker, then installing Kubelet, Kubeadm, and Kubectl. And then finally, I'll be setting up the configuration C group settings. Now, for your ease, if you don't want to see me typing, we will be replicating all these steps on all the 3 nodes. So you can take these commands from the blog k21academy.com/Kubernetes 30 and follow the steps on copying the commands and putting it into all the 3 nodes. So if you notice, I've connected to these 3 machines. This is my left extreme master node. This is my worker node 1, and this is my worker node 2. And I'll be installing the software on all the 3 machines, which is Kubernetes Docker, Kubeadm, Kubectl, and Kubelet. So I'll switch to root user. I'm going to repeat this on all the 3 machines. So I'll show it on one machine, and then assuming we are repeating on all the 3 machines. So picked up and said apt get update, and then installing and saying docker.io. Hit enter, and this will now download the Docker software and install Docker on this machine. Now, once the Docker is installed on this machine, I'll check the Docker version, and it is installed 19.03.6. Now, maybe when you're doing in future, you might get the latest version of Docker, but which is fine. Then I'll also need HTTPS to be enabled, transport HTTPS. So I'll install it on all the 3 machines using this apt-get. Now, all these commands will be available on our blog, k21academy.com/Kubernetes 30. Now, in order for me to install these Kubeadm components, I'll first set up my packages or add the keys for the packages from my package manager on Google Cloud, because that's where I'm downloading these from. So I added the keys, and then you need to copy this exec command. So what it's doing is it's updating the entry into my etc apt source list.d inside that kubernetes.list file. So if I go and do a cat, you should have an entry on my Kubernetes file, this file saying that my Debian, this is my URL for my Kubernetes, which is apt-kubernetes.io. I'm updating my get update. I'm downloading all the latest software on this Ubuntu machine. And this is the main bit, this is where I'm getting all the required software, which is Kubelet, Kubeadm, and Kubectl on this machine. So once I've installed these Kubectl, Kubeadm, and Kubelet, I'll update the configuration file, which is kubeadm.conf, with adding a C group arguments, which is saying which driver I'm going to use, which is a C group FS. So if I cat on this file, which I've updated just now. Now again, this sounds cryptic and this is one-time job, and I hope you understand behind the scene what's happening. We are setting it up Kubernetes cluster and setting up all the necessary permissions or the settings on this. And finally, I'll be reloading my Kubernetes services, which is Kubelet, and I'll be restarting my daemon. So I'll say restart all the daemons. And on this warning, if you get a warning, that's totally fine. Don't worry about it. Now you need to repeat all this on both worker node and master node. So I'm assuming you've already done both the setups on both master node and worker node. So now I've done all these tasks in task number 3, which is installing Kubeadm, Kubectl, Docker, all these required software on both master node as well as worker node. And I've restarted my daemon, restarted my kubelet process on the Kubernetes cluster as well as worker node. So let me go and do the same thing on both the worker nodes as well. And then we'll be initializing my cluster on master node and joining both the worker nodes onto this master. So once these utilities are installed, like tools like Docker, Kubectl, Kubeadm, and Kubelet, once these are installed, now we are ready to initialize the cluster. And so we'll run init, kubeadm init, that will initialize the cluster on the master node. And then on worker node, when we run the kubeadm init command, we'll get a command to join the output on from a worker node. We will then run that on the worker node so that my worker node can talk to the master node. And then it will generate a config file or admin.conf. That will be my kube config. So any command that you run in future like kubectl, that you need to make sure that kube config is set properly. Your environment variable kube config will be set so that your admin.conf is called and it will set all the parameters. So let's first go to the master node and run or initialize the cluster, and my worker node will join my master node. So I'm on a master node. Make sure you have logged in as root user, and we did all those labs so far on root user sudo su minus. Now I'll say kubeadm init. Now this is initializing my cluster. So Kubeadm will do all the hard work for you and set up this Kubernetes cluster. And if you're appealing for certification, you should be familiar with Kubeadm. So if you look what it's doing, it's bringing all the Kubernetes master node will run itself inside a Kubernetes cluster. So it's bringing all that image of different components that are part of Kubernetes cluster, or a master node will be bought over the internet and downloaded on this machine here. Now this, when you run kube init, it'll give you a command to join my worker nodes. And I need to run this command on all the worker nodes. So this is my worker node 1. Make sure I've logged in as a root user, and I'm saying join my cluster or a master node. And similarly, this is my node 2 or worker node 2, and I'm setting up the worker node both. So if I right now run kubectl get nodes, so get kubectl is a command to run all my Kubernetes cluster commands. So kubectl get space nodes. And if you see here, I'm getting this error, which is connection to the host server was refused. And this is because I've not copied my kubectl or admin conf or Kubernetes config file, or this file is not in the path, or my environment variables are not set basically. So what I've done is I've copied this file under user home directory. So, and if I do cd ls-l, and I've set the permission to read write on to the user only, and my admin conf is set. So if I do cat on admin.conf, it will have all the variables or all the parameters to connect my worker node, master node, client certificates, and where my server is running. My server is running on this host, on this API server. So it has all the details of my API server, etc. And if I do echo $kubeconfig, that environment variable should be set. So that's important for you to understand. Now, once I've done, this is my root admin.conf, and now I'll be able to run get nodes. So I'll say kubectl get nodes. Now, if you see still here, I can see my worker node 1 and worker node 2, but their status are not ready. So that means I have one final step, which is task 5th, which is install CNI, which is the container network interface. And there's only one command which I'm going to run using kubectl, and I'm downloading. There are different type of network plugins or container network interface I can download. I'm using a Weave. And again, what are the different networks? The documentation, I'll put it on our blog, k21academy.com/Kubernetes 30 or Kubernetes 30. So I'm going to run it on master node, and that master node will apply that. If you see, it has created all the network. It has also created all the role-based access control, RBAC, and authorization and the permissions. So once you give it a few minutes, and then all the worker node will be able to connect to the master node, and you see now kubectl. This time, if you see get nodes, your status is ready. So earlier it was not ready because networking was not enabled. So I've enabled CNI, and now if I do nodes and pods, so I'll see by default kubectl and get nodes. I've already seen that. Now we'll see kubectl get pods. Now by default, right now there's no pods installed, and there's no default namespace. Namespace is basically logical breaking down or a logical partition of this Kubernetes cluster into the smaller one. So there's no namespace defined. So I'll say get pods -n. If I run a default namespace, which is kube system, and here my by default in the master node, the default namespace, in that default namespace, I have all these pods running. which are basically the master node components running inside a pod. Now, what is pod? I've done a detailed post about what is pod and how do you deploy the pods. And in future, we might create some labs on creating pods. You can check everything about pods by going to K21Academy.com/Kubernetes 26. So that successfully have completed your installation of Kubernetes cluster on a 3-node Kubernetes cluster. Now, if you have followed it through so far, big congratulations. Now it's your turn to go and create these Kubernetes cluster on using step-by-step procedure. Now, this Kubernetes cluster creation creates or have a big weightage, and especially when you're preparing for the certification, which is a CKA or CKS, Certified Kubernetes Administrator or Certified Kubernetes Specialist or CKS. If you want to know more about these certifications, CKA or CKS, you go to K21Academy.com/Kubernetes11. And for a list of all the hands-on labs you must be performing, you can go and check it out at K21Academy.com/Kubernetes05. So just to do a quick recap, you'll be first creating 3 machines, then ensure that all 3 machines can talk to each other. We created these 3 machines on Azure Cloud. We enabled network peering and we opened the port number through Network Security Group or NSG. Then we installed Docker, Kubelet, Kubeadm, and Kubectl software. Then we initialized the Kubernetes cluster using initialize or init Kubeadm. And then we joined both the worker node to this master node using kubeadm join command. The final step was we installed network or CNI plugin of type Weave so that my cluster members can talk to each other, including pods can communicate to each other, including the DNS configuration. And finally, we check the status of a node and pod. Now, one final thing is once all these nodes or tasks are done, go to the virtual machine, select all these virtual machines and make sure you shut down all the machines so that you don't get charged for these machines. So select here all these and click on stop, and that will stop all the 3 machines that are running so that you save some money for further practice, and we'll be using these Kubernetes cluster on in future any labs with that we do or we recommend you to deploy in order to learn Docker and Kubernetes. Now, this step-by-step guide that I mentioned or highlighted, which I used here, which is creating or bootstrapping a Kubernetes cluster using Kubeadm, I'll be uploading this guide on K21Academy.com/Kubernetes30, Kubernetes 30. So there'll be a link there so that you can download this guide and practice this on Kubernetes cluster that will have or deployment of Kubernetes cluster on 3-node cluster. There'll be a step-by-step instruction. So get this free copy by going to K21Academy.com/Kubernetes30. Well, that was one of the step-by-step hands-on lab. And like that, we have around 38 or 39 hands-on labs that we recommend for you to you can check that by going to K21Academy.com/Kubernetes05. In that, all the labs that you must be performing, and these are specific to Kubernetes, they'll be Docker specific as well. All the labs that you must perform in order to not only learn Docker and Kubernetes, but also get certified on Kubernetes, which is Certified Kubernetes Administrator. If you want to know what to expect in the exam, I've done a video last week, which is K21Academy.com/Kubernetes11. That video will have everything you must prepare in order to successfully not only learn Docker and Kubernetes, but clear your exam, which is Certified Kubernetes Administrator. So K21Academy.com/Kubernetes1111. Now with that, this is Atul from Team K21 Academy talking about step-by-step procedure to create a 3-node Kubernetes cluster taken from our program, which is comprehensive training program talking about Docker, Certified Kubernetes, and certification CKA, including 1 year on-job support for the program. Now, if you're not certified, I would like to invite you for a free masterclass on how to kickstart your journey in Docker and Kubernetes, right from learning basics, what is Docker, what is Kubernetes, and getting certified by using our step-by-step 12-week roadmap to go from complete beginner to a certified Kubernetes administrator. If you're interested, register for a free class by going to K21Academy.com/Kubernetes02. Now, next batch of the training is starting on 19th of October. So few days after this video gets published. And if you're watching this in future, I still highly recommend you to go through this free class to see what to expect in the exam and to learn basics on Docker and Kubernetes. So K21Academy.com/Kubernetes02. With that, Atul from Team K21 Academy, I'll see you next week with another episode on Docker and Kubernetes. Till then, Take care.